Here we go. Remember I said this week and next week our goal is to go through 6A and 6B. That's minimum. If we can get to 6C and 6D, then that finishes the term and then I'm pretty happy with it. But 6A and 6B, mainly 6B, being the key skill. Let's have a look at what you need to know for 6A. 6A, most students usually pick up, and I'm going to show you an example from the foundation exam that you pretty much use this basic skill here to answer the first question. Let's have a look. Ratios is very similar to fractions, but we use it specifically for its simplicity, okay? And it doesn't include the units. So let's have a look at this. Let's say for this diagram, the first one on the left here, how many equal parts can you see there? Can I please have, let's go with Adele. How many equal parts do you see? Three. So we've got 1, 2, 3 equal parts there. And if I said out of those 3 equal parts, how many are shaded? Can I please have, let's go with Zara. How many are shaded? 1. So we can see that there's 1 that's shaded to how many unshaded? Let's go with Willow. 2. So we say shaded to unshaded is in a ratio of 1 to 2. Let's have a look at the second example then. How many are shaded in the second example? Yichen. 3. To how many unshaded? Let's go with Ollie. 7. How many total parts are there in this second example? Let's go with Jacob. How many total equal parts are there? 10. There's 1, 2, 3, 4, 5. So 5 on the top row and therefore 5 on the bottom row. So it makes it 10. So 6, 7, 8, 9, 10. Now, one of the things that students generally find hard is actually not having a diagram. So most times you don't have a diagram and it looks like this. So I would say something like, shaded to unshaded, or sugar to water, ratio is 1 to 2, 3 to 5. Amount of paint or marbles or boys to girls. The ratio is this. And I find it's interesting that with a diagram, most students will be able to answer me. But without a diagram, the total number of parts students get wrong. And there's something about just seeing numbers versus visualizing what's actually happening. See, this one made sense. It was a total of 3. This one you counted 10. But if you just had the numbers without the diagram, how can we quickly figure out the total number of parts? What would you have to do? Without drawing it. Without drawing it, if I just said 3 to 7, how would you know that it is 10 straight off the bat? What's a way to calculate it?
3 plus 7.
Very good. Add the parts together. Because 3 is shaded and then 7 is not shaded. So 3 plus 7 will give you 10. 1 plus 2 will give you the 3. So even with this one, it's 5 to 4. So I should do it in pink. Let's do it pink again. 5 to 4. Without looking at the diagram, how many equal parts should there be? Let's go with Willem. How many total equal parts for a 5 to 4 ratio? 9. Now again, can you guys see, without the diagram, see, had I asked everyone that I've asked so far, everyone answered very quickly. But as soon as I did that, there was a bit of a slow response there. Partly because Willem was probably doing something else as well. But can you see, the idea is that if I gave you a diagram, there's something about it. Diagrams help you visualize the problem. So if it helps you when you're doing ratio problems, draw it. Don't just rely on the numbers. Draw out the problems. It actually makes it easier to problem solve. So with this diagram, had I asked him before, I said, how many equal parts are there in this diagram? He will likely have answered 9. 3 by 3 gives you 9. But that's the thing about just numbers. Try to visualize what's happening. 5 parts to 4 parts gives you a total of 9 parts in total. Now, today's lesson, when you say these parts, part of it, there's an intuition as well. Since the total number of parts is 3 for the first one, 10 for the second example, and 9 for the third example, inherently, this is why ratios and fractions are linked. See, out of 3, you told me 1 is shaded. So in essence, you're also saying a third of that block is shaded and 2/3 of that block is not shaded. Same thing with this one. This total block, when you say 3:7 ratio, what you're implicitly saying as well is that 3 out of 10 is shaded. So 30% of it is shaded. And then 7 out of 10, which is 70%, 70% of it is not shaded. See, the language that I'm saying, that has more meaning to students and people. But when you say 3:7 ratio, that's not what people think. People don't interpret that way. Your challenge is to convert the language of ratio into something meaningful. So when I say 3:7 ratio, what I'm actually saying is 30% of whatever it is that you're looking at and 70% of whatever it is that you're wanting. Yeah? Same thing with this one. This would then mean for this block, 5 out of 9 is shaded and 4 out of 9 is unshaded. This is going to be important to understand for 6B. 6B relies on the fact that you use that proportion to then solve a problem. But before that, today's lesson is literally just learning to simplify ratios and finding things that are, and fill this in, ratios can be multiplied or divided by a factor to give an equivalent ratio. Write this in. Equivalent ratio. Write that in. Just like how you did in fractions, half is equal to 2/4, is also equal to 3/6, is also equal to, give me another fraction that is equivalent. Let's go with Nick. So half is 2/4, 3/6. Well, I already got one half there.
36.
Whoops. So you mean 18/36. 18/36 is a valid answer as an equivalent fraction. Give me another one. Let's go with Charlotte. 20/40. These are all equivalent fractions. They're written differently, but they're all equivalent. 20/40 is still half. 18/36 is still half. And what is connecting them all is by multiplication or division. See, from half 1 to 2, I'm timesing by 2. Whatever you do to the top, you do to the bottom, right? Or you could go backwards. You could have gone from 18 to 3. 18 divided by 6 gives you 3, and 36 divided by 6 gives you 6. That's what that line means when I say ratios can be multiplied or divided by a factor to give an equivalent ratio. So if you can do it for fractions, you can definitely do it for ratios. It's just that the way it's written, students look at this and get confused. So let's have a look at this example. You got a 1 to 3, but I want to know what is that equivalent to if it was, and I'll give a scenario just to make it easier for you to understand. If it's a boy to girl ratio, for every one boy there are 3 girls. If I told you there are 6 girls, how many boys are there in this class? Because I know the ratio is 1 to 3. How many boys should there be? 2. Now the question is how? How do we get there? So how did Attila work out that the number of boys in this class has to be 2 if I know the ratio is 1 to 3? The how is what I wanted to figure out. So let's work it out. What did Attila do to get 1 to become 2? What did you do?
Times it by 2.
Times it by 2. But the question is, where did this number 2 come from? Because you have to know what you're timesing to, right? So you knew 1, but then you're timesing. What are you timesing it to? So how do you not find that number? How did Attila, or how do you think we would find the number 2? Because that's the factor. What do you have to do to get the number 2?
6 divided by 3.
Okay, good. So he took 6, which is the girls, and we're comparing it to these girls over here. And we're taking the final number. We're looking at this side. We're saying this number to 3. We're saying 6. How many 3s fit into 6? That is why we did 6 divide 3, and that's how we get 2. Now, that's not the only way to do it. See, you could have done it the other way as well. You could have said, well, how many 6s fit into 3? It could have been this way. It could have been from this going to this one. Now, if you're going from 6 to 3, how many 6 fits into 3? How many 6 fits into 3?
6 into 3.
Yeah, which is the same thing as saying 3 over 6. Because 3 over 6, this means how many 6 fits into 3. Yeah? When you say 3 divided by 6, it means how many 6 fits into 3. What's 3 over 6? 1/2. Which is why I was doing this before. I was doing this to link it back so that you understand the language. This means how many 6 fits into 3? You told me it's half. That's your factor. Now that's your factor. Do you realize you could have done 6 times half to get to 3? That means you could have done whatever this number is. 2, half of something gives you 1. So half of 2 gives you 1. That's another way to do it too. Okay? So half of something gives you 1. That's why we know it has to be number 2. Now, I'm going to give you one problem so you can see, thanks, why this one is easy. And then when I give you a different number, students struggle to work with it. So let's show an example. Copy this one down just on the side. So you were able to do, when I say 1 to 3, and I asked you, what is it equivalent to 6, right? You told me it was 2. Great. What happens if I change the number, just very slight change, and I say 5? Because this one is where it's interesting, because intuitively, that's the thing about maths. A lot of students do things intuitively. I'm not about the intuition, I'm about the logic. How do you go about finding this one? So if I were to do this as a test, I would do this one to see if students know it intuitively. Then I do this one to see if they know their process. Then I do another one to see if they can problem solve. That's how I do it. Because then it tells me a lot in your thinking. How do we do this one? So now I'm testing process. Because if you could do the first one, you can definitely do the second one. Because there's a process. But if you memorized it or did it intuitively, you won't be able to do the second one. So, what's the answer for the second one? And how would you do it? Ryan? Okay, and how did you get 1.25? You don't know. So he's got 1.25. That's his answer. I'm interested in the how. See, I'm not interested in guessing. Maths is not about guessing. It's about doing and figuring out. It's black and white. Does she have any hand up?
It looks like the remainder of what to get this would fit into 5 is the answer.
Yes. You just got to spell that out a bit more, but you're correct. Did you want to elaborate what Quelia was saying? No. Okay. I'll elaborate on what you were saying. So Quelia was saying, just like what Attila did before, you knew how many 3s fit into 6. That was convenient that it was double the amount. But what if it's not? Because in life, most things aren't convenient for you. It doesn't always work in like nice whole numbers. It's the same logic. How many 3s fit into 5? Now, if you write that as a fraction, how many 3s fit into 5? It's 5/3. This one was, boys. Thanks. You've been talking while I'm speaking, and I paused a couple of times, but you continued. It's disrespectful. You don't want to listen, don't listen, but you just sit there quietly. Or take notes, but you don't talk while I'm speaking. Here we go. So if you look at what Attila did before, we said, well, 6, how many 3s fit into 6? That's how you knew you times 1 by 2. Then same with the same logic here, we're asking how many 3s fit into 5. Now, you don't actually have to work out the decimals for this unless you really want to. You don't need a whole number. You can leave it as a fraction. It fits in 5/3. So then what do you do to the 1? Times it by 5/3. You don't have to have a whole number. You don't have to do 1 times 2. You can do 1 times 5/3. Because that's literally what this means. How many 3s fit into 5? Now, as you work it out, 1 times 5/3 gives you 5/3. Now, if you really want to know that as a decimal, then that's where you use what you learned back at the start of this year and last year as well. Division. Let's go. How many 3s fit into 5? I'm going to write out as a decimal here. But remember, you got a calculator. You can actually type this up in the calculator. 5 divided 3. You get the decimal. Well, let's work it out. How many 3s fit into 5? 1 remainder 2, so 1 dot, carry the 2. 2 goes over here, that's now 20. 3 goes into 20. How many 3 goes in 20? 6, remainder? No. 3 into 20 is 6. Remainder? 3 times 6 is? So remainder? 2. So you carry the 2. So again, 3 into 20? 6, 6, 6. So Ryan was close, but not close enough. He said 1.25 before. The answer was actually 5/3, which is actually the same as 1.66. But I would prefer that you actually write your answer as 5/3. Now here's a problem. We don't write our ratios. You will never find in a Bunnings or anything like that with ratios where they write, or even cooking, they don't do 5/3 to 5. We don't mix fractions with ratios. Okay? So if you have something like this, 5/3 to 5, you don't leave your answer like that. You're actually meant to convert it so it's an even, like a whole number. Now let's think about it. That's in thirds. That means divide 3. So if I have 3 of them, okay, or you do the opposite of division, what's the opposite of division? Times. So if you have 3 of them, times it by 3, times this side by 3. So whatever you do to the left, you must do to the right. 3 times 1/3. What's 3 times 1/3? Well, if you're confused here, what's that? Well, that's my year 9s. Let's do it again. This is divide by 3. So opposite of dividing by 3. If you want to get rid of the 3, times by 3. But notice 3 times 5/3. Going back to fractions again. 3 times 5 is 15, or cross-simplifying, you get 5. So when you times the 3 on the left-hand side, this actually ends up being 5 to 15. You see that? This is the ratio I would like you to write. Instead, if you got 5/3 to 5, that is the way you write it. But conveniently, 5 to 15 is the same as? Because you're just dividing by 5. And that's what today's lesson is. So in one example, you see one was intuition. Most students can do. Next one, all I did was just change a digit. One digit, one unit, from 6 to 5. And can you see the level of mathematics that I'm using? I'm using everything that you've learnt previously to problem solve. And that's proving 1 to 3 is equivalent to 5 to 15, which is the same thing as 5/3 to 5. Okay? All right, team. Let's do some examples. Example 1. Let's have a look at this example. Example 1. In a bag, there are 3 green marbles, 7 marbles, and 6 marbles that are red. So 7 blue, 6 red. How many marbles in total are there? Can I please have, let's go with Hamza. How many marbles in total? There are 16. Yes, you're right. 3 plus 7 is 10. 10 plus another 6 is 16 marbles in total. So when they say, write the ratio of green to blue to red, so that every time you say the word to, that's your semicolon, right? So that's the semicolon. So green to blue to red, what's the numbers? I've got 3 greens, 7 blues, and then 6 red. So you should have 3 to 7 to 6 in that particular order. Yeah. Okay? Next one, B. What is the ratio of green marbles to the total number of marbles? What would the answer be for this one? Let's go with Zara.
3 to 16.
3 to 16, very good, because it was 3 greens and then there are 16 total marbles. And notice that you have to simplify your ratios if they're not in simplest form, but in all of these you can't simplify any further, so that's fine. Last one of the examples, ratio of blue marbles to other marbles. What does other marbles mean?
Green and red.
Green and red, very good. So blue, how many blues do we have? 7. How many other marbles do we have?
9.
9, very good. 7 plus 9 should add up to 16, and it does. So it's a 7 to 9 ratio. This is what you're doing in the first exercise. Exercise 6A is just working with writing ratios and figuring out ratios. So this is the one that is intuition. So most of you should be able to figure this one out. What number goes into example 2A? If it's a 3 to 10, then it's 9 to 30. Very good. That's intuition. 30 to 20 becomes? Good. So 20 to 4, we had to divide by 5. So then 30 divided by 5 gives me 6. This one was 9 divided by 3 gives you 3. And therefore 30, or you can think of it the other way around as well. 3 times 3, 10 times 3. Okay? Now, I want you to copy these two examples down in the back. Can you copy down this example just in the back, turn over? Write 2 2/3 to 3 1/2. So what do you do when you have fractions? Because remember I said ratios, we never mix fractions with ratios. You have to write them in integers, which is whole numbers. That's in fraction. But not only that, it's in mixed fraction as well. So we got to get rid of them. Here we go. Here's the technique. We got to convert mixed fractions to improper fractions first. Let's see who remembers. Jacob, how do I convert 2 2/3 to improper fraction again? Forgotten?
Will be 6. 6 over 3.
Oh, so close. 6 over 3 is actually equal to 2. 6 over 3 equals to 2. So that's how you get your 2 wholes. So that extra 2, what do we do? Plus it. Very good. Because that's what it means. 2 wholes is 6 over 3. And you've got another 2/3. So if you add them together, 6 over 3 plus 2 over 3 gives you 8 over 3. But the actual trick that most of you would have learnt and memorized was that you take the denominator times the whole number and then add the numerator. So that was the trick that you guys learnt. I don't like those tricks because it really takes away the mathematics and understanding why it works. What you were doing was actually pretty good. If you converted the 2 into 6 over 3 and then you added 2/3, then that would have shown why it's equal to 8 over 3. But there we go. So that will give you 8 over 3 as an improper fraction. Someone else convert now. Let's go with, who would I pick? Charlie. 3 over 3 1/2 becomes what as an improper fraction? 7 over 2. Very good. So again, 2 times 3 is 6. Add the 1 in the numerator, so you get 7 over 2. Now we've moved away from mixed to improper. Again, like I said, we don't want fractions. We need to get rid of denominators. What was the trick I just showed you to get rid of that denominator 3? What do you do there, Garissa? How do we get rid of that 3? Times by 3. Okay, so that means divide 3 times by 3. But whatever you do to the left, you must do to the right. So 3 divided by 3 cancels out to be 1. So I end up with just 8. 2. Now remember when you're multiplying fractions, writing 3 as a fraction is 3 over 1. So top with top. 7 times 3 is 21. Over 2 times 1, which is 2. Now this side is still a fraction. How do I get rid of that now, Nick? Times by 2. This is divide 2. So then I say times 2 to the right. But whatever you do to the right, do to the left. 2 divided by 2 cancels out. So you end up with 2 times 8, which is 16, to 21. Is that in simplest form? I think it is, yeah? 3, 4. Yes, it is. 16 to 21 is the simplest form. So that's one of the techniques. Make sure to copy that example down so you know how to convert fractions. Boys, it's copying notes. It's not to do with your laptop at the moment. So please put your laptops down. Here we go. So we got now fractions sorted. The last one, or second last one, because I'm going to show you some foundation examples and see if you can figure them out using the skills you've learnt. What's wrong, or what's the problem with 40 seconds to 2 if I wrote it like this? Very good. They're not in the same units. And why does that matter? Why does the units matter? Because this means if you say 40 to 2 and you simplify that, that's 20 to 1. That's like you saying for every 20 seconds, there's 1 second to the other side. But that doesn't make sense because there are 2 different units there, right? Because this is minutes. That's actually every 60 seconds, right? So when you say 2 minutes, that's actually 2 times 60, which is 120 seconds. That's a different ratio to 40 to 2. So one of the first things you always have to check is when you're comparing actual things, when you're working ratios, you need to make sure the units make sense, okay? So in this case here, it should be 40 to 120, and therefore we can then say that becomes 4 to 12 because it's dividing by 10. And then you can also say from 4 to 12, what's a common factor? 2 or 4. Divide by 4, divide by 4. 4 goes into 4 once, 4 goes into 12 3 times. So this is a ratio of 1 to 3. So when you say 40 seconds to 2 minutes, it's a ratio of 1 to 3. So for every 1 second, the other side is 3 times that amount. Okay? That's one of the ideas. Copy that down, and that's pretty much it for 6A. It's problem solving, it's simplifying. Then I'm going to show you 2 questions from the exam. The first one you should all get, or at least feel confident to get. The second one, some of you may stumble a bit, but you'll eventually figure it out if you pester with it. Here we go. Here's 2 questions from the Year 12 Foundation exam in 2024. Let's have a look at this 2. I'm just going to leave it there. See if you can figure out the answer. This is question 1. 76% of students got it right in 2024. And this one, I think it was about 54. So half the cohort got this one right. The exam average was 26%. So it's a very long exam. And most students struggle with percentages. Have a go with that one. I'm going to stop the video.